Hey, Top Airlines Math Industry, and we're gonna understand everyday reasons why math is important daily. So, in this video, we're gonna do an example problem that relates to real life. And the reason why math is important is because you will do a lot of calculations in your everyday life, like what is the area in inches of that TV? Or what is the precipitation in inches? While doing math every day, it can help us make things much easier and efficient. Here's an example. An airplane has 7,682 liters. The pilot orders you to have the passenger jet have a total of 22,300 kilograms of fuel. How much fuel do you have to load up the plane in kilograms? There is a 3-step process to solving this problem. The first step is find the weight of the fuel already on board. The second step is subtract the required amount of fuel by the fuel already on board. Then the third step and the last step is convert the weight of the fuel back to the volume. So let's start with the first step. Find the weight of the fuel already on board. Well, in the beginning of the story problem, the airplane already had 7,682 liters on board. It is very rare for an airplane to land at an airport with exactly 0 liters or 0 gallons of fuel. It is very rare for that to happen. So the plane is definitely going to have some fuel left from the last flight. We have to get our answer in kilograms. But how do we convert liters to kilograms? Well, what we're going to have to do is find the density. And the density for fuel per kilograms is 0.803 kilograms per liter. That is the density. The formula for density is the mass divided by the volume. That will bring you to the density of a liquid or a solid. And for fuel, every liter that you have is going to weigh 0.83 kilograms. And the liter is actually measured in volume. Liters is actually in volume. So, every liter you have is 0.83 kilograms. So now, what we're going to have to do is multiply 7,682 liters by the density. That will bring you to the amount of fuel in kilograms already on board the airplane. And when we multiply these two numbers, we're going to get an answer of 6,199 kilograms of fuel. What we just did is step number 1. Find the weight of the fuel already on board. So now we have to go to step number 2. Subtract the required amount of fuel by the fuel already on board. This is the easiest step. So the required amount was 22,300 kilograms. And we have to subtract that by 6,199. Because if you try loading up the plane with the required amount of fuel, that means the fuel tanks will overload, and that would be bad. So, since there are already fuel on board, you can't fuel up the plane with that much. You have to have a total of that much fuel. So, we're going to get an answer on step 2, the amount of fuel that needs to get onto the plane with the fuel truck. 22,300 kilograms subtract that by 6,199 kilograms, we're going to get an answer of 16,131 kilograms. That's how much fuel needs to get onto the plane. So now we have completed step number 2. Now we have to do step number 3. Convert the weight of the fuel, and you have to convert it back to volume. So now we have to turn this kilograms back to liters. So if 16,131 kilograms is the amount of fuel that needs to get onto the airplane, we're going to have to divide by our conversion, or 0.803 kilograms per liter, because that was the density. When you're fueling up an airplane, the density is going to be your converter to get from a measurement to another measurement. So when you have two of the same measurements, that'll be really easy to add, multiply, subtract, or divide. So this number divided by our conversion, we're going to get an answer of 20,088 liters of fuel. So the amount of fuel that needs to get on the airplane is 20,088 liters of fuel and 16,131 kilograms. The reason why we have two answers is because the pilots want to calculate their fuel in weight, like pounds, kilograms, ounces, grams, and the ground crew with their fuel truck will calculate the fuel by volume, like liters, gallons, quarts, ounces. So, this is how much fuel that needs to get on the airplane. You know what we have just solved? We have solved the correct calculations for the fueling records for Air Canada Flight 143 in 1983, July 23rd. So, on July 23rd, 1983, Air Canada Flight 143 was a Boeing 767, and their captain was Bob Pearson. Bob Pearson was the person that demanded the fuelmen to load up the plane with a total of 22,300 kilograms. But the problem is, it almost crashed because there was a conversion confusion with the metric system and the US system, like pounds and ounces. The plane almost crashed, but it actually glided to an abandoned Air Force base. That's why the plane is called the Gimhe Glider. The word Gimhe is the name of the Air Force base, and glider because the plane has glided with no engines right at the airport safely. No injuries or no fatalities happened. Everyone has survived the incident. Well, how did the plane crash? Let's see the calculations that the ground crew did inaccurately and see what their mistakes were. So, the mistakes are written in red. So, they did 7,682 liters normally, but they multiplied by 1.77 pounds per liter. That is the density. Every time you have a liter of fuel for an airplane, if you measure in pounds, it would weigh 1.77 pounds per liter. And they miscalculated how much fuel is already on board the plane. 13,597 pounds of fuel. Then they did 22,300 kilograms. Subtract that by 13,597 kilograms. They forgot that it was pounds and not kilograms. That was a metric system error. And that brought them to 8,703 kilograms. The fuelmen forgot that it was pounds, so they already made one mistake. Then they had 8,703 kilograms. To convert it back to liters, they had to divide the density, 1.77 pounds per liter, and that brought them to an inaccurate answer of 4,917 liters. And since 1 kilogram is 2.2 pounds, that means the airplane took off with half of the fuel it needed to get to its destination. Air Canada Flight 143 started in Montreal, and where they were going to go to their destination is they were supposed to get to Edmonton. But since they had half the fuel, they only made it half to their destination. When they were here, 700 miles away from Edmonton, their destination, they realized that they had ran out of fuel, and the closest airport that could have a 767 land at their airport safely was at Winnipeg, but that was 110 miles away, and they didn't have enough fuel, so they were pretty much free-falling. And instead, they diverted to an airport named Gimhe. It's not on this map, but it's an abandoned military airport, now used as a race car circuit. And they had safely glided and landed their plane at the racetrack. The calculations for loading up the plane with fuel was not the only thing that contributed to this almost crash, but with the airplane actually indicated the pilots in the cockpit controls that they actually had enough fuel, but the plane thought it was in kilograms, but the fuelmen were accidentally loading up the plane in pounds. And the newly Boeing 767 that they recently ordered actually uses the metric system. And that was their first airplane in the fleet to use the metric system. All the other planes previously bought by Boeing and other companies were using the U.S. Imperial system. But the plane they were flying on July 23rd actually was the first plane in the fleet to use the metric system. So there was a big confusion with the math. But how did Air Canada learn from this mistake? They now require pilots to learn the metric system and the U.S. Imperial system. They also require to do some math teaching, and they actually have to learn how to convert from one measurement to the other one. So it's easier when you have two of the same measurements, so you can add, subtract, divide, and multiply. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.